Alright everybody, so today we're going to be going through a brief version of, or truncated version of Required Practical 4, which is an investigation to show the effect of temperature on the release of red pigment, or betalins, betalins, if you want to call them, from beetroot tissue. So obviously this is, well, the bulby bit of a beetroot, and as you may know, beetroot has this very vivid, very sort of, that sort of bright, sort of purpley red pigment in it, and this is, in essence, in terms of the actual protocol, it's fairly similar to our osmosis experiment in Required Practical 3. There's going to be some coring using our handy cork borer, and then we're going to be submerging our equal length beetroot cores in a solution in these test tubes or boiling tubes. But instead of, in osmosis, those solutions being of a different water potential or sucrose concentration, they're all the same. They're all a buffered, pH 7 buffered, effectively pure water with a bit of buffer in them to make sure there's no acidic degradation of cells, or alkali for that matter. And we're going to be, instead of investigating the variable of water potential, we're going to be investigating the variable of temperature. So I've written down here, I've set up, although you can't see it because it's off screen, I've got 4 water baths. Yeah, so I've got 4 water baths at 30, 60, 70 and 80 degrees centigrade. I have a room temperature set up, which is about 20 degrees. I will make sure the data is actually accurate on the graph that you'll be given, on the data you'll be given. And we've got a, I'm going to have one of these boiling tubes set up in the fridge, which is at about 4 degrees currently. So we've got a nice range of temperatures there, which should give us some interesting results, and we'll see what effect they have and what trend that might denote. So, simply put, we're going to start coring our beetroot, similar to how we did with the potato. So I'm just going to slice the top off, and you can already see we've got these pigments starting to come out already, so it's not hard to get these pigments to come out. And just to make it easier to actually cut this thing, I'm also going to slice the bottom off, so I've got a relatively square thing to push a force into. So we're going to need 6 cores. I'm going to do them as at 15mm this time instead of the 20 that they were for RP3. So we're just going to core that through, and I'll use my very appropriate, very handy poking stick, which is not at all just a pipette. So maybe push the beetroot out a bit. Come on. Oh, a little bit. I'll have to get a longer stick. Yeah, because beetroot's firm, I'm going to need to get a longer stick to poke. Right, so now I've retrieved my very, very proper glass rod. That's a lot easier than using a pipette. So we've got our, I could probably get 2 cores out of that if I was feeling particularly brave. I'm going to core an extra couple just in case. So yes, apologies for anyone with was it trypophobia, whatever it's called. This isn't exactly pleasant to look at for some people. Probably get, oh, we can double check. Oh yeah, we can probably, we can easily get 2 cores out of each of those. And then trying to conserve this a bit. Okay. So now we're going to try and cut these as uniformly as possible to 15mm long cylinders. So that's 1. And again, if it doesn't look like it's dead on the line from your angle, I promise you, I'm being as close as I can. One, 2, 3. Maybe not quite as perfect as my potato cores have been, so I'm just going to square this end off a bit. discard of those. So 2 more, 15 ml each. Not too bad. I've seen worse. I've done worse. Okay. So now we've got our cores. We're just going to place them into our 6 boiling tubes, and we're going to leave them in their respective temperature water baths for 10 to 15 minutes, I believe. 10 minutes. Yeah. So it's 10 minutes, and we're just going to let the pigments seep sort of however quickly they're going to, depending on the temperature. Then once we've done that, I'll show you what we're going to do with regards to these little cuvettes, which I've just noticed I might have got some pigment on. So, well, hey, luckily, I believe I'll fix that. So, be back in a moment. Alright everybody, so I've just finished the 10-minute incubation in the various temperatures of water bath or in the fridge or on the side of the lab. And we've got some interesting results just already from the onset. So this is our fridge one, which is about 4 degrees centigrade, and you can see there's an amount of pigment being released. It's largely sort of pooling at the bottom by the core. On the other end of the scale, we've got this, which is our 85 degree. Now you'll notice here on this that I have modified the actual temperatures measured with my thermometers versus what I thought they should be. Very important to actually get the accurate temperature rather than just assuming that the thing set to 30 degrees is going to actually be at 30 degrees. So there's a bit of variance, but most of them are in the same sort of ballpark. So what we're going to do now is we are going to transfer some of our red sort of solution from the boiling tubes into their respective cuvettes. We could use a test tube and just put it straight into this colour emitter, but we've got the cuvettes, I might as well use them. A bit more fun that way, a bit more to show. So we're going to use there are actually 3 different pigments within Beetroot that I didn't realise had slightly different wavelengths of light that are best absorbed, or at which they are absorbed better, or the results are better shown at these various wavelengths. So I think there's one like high 400, so maybe 485, which we might. So it's sort of the green to yellowy green spectrum effectively, so 480 to about 540 nanometer wavelength. Now I'm going to just do the 520 nanometer as a sort of midline or sort of median wavelength in that range. But I will also provide data to your teacher with the results for other sort of spectrographic analyses as well. So you might be able to find some interesting variance in results there, you know. Which is better released? Which of these 3 pigments is better released from in certain temperatures? Perhaps might be something to think about. So what we're going to do here is obviously you might be able to see better with this one. If the sort of you can see the sort of this billowing pigment that might be settled at the bottom because it's heavier than the water around it. So what I'm going to do is just gently vortex with a pipette, just to mix and get a nice even concentration of this pigment, and then I'm going to transfer it into our cuvette, being very careful just to hold the opaque sides, and that should be enough, but I'm just going to make sure that it's filled to the appropriate level. So as long as it's just underneath, you might be able to see the arrow. Quite sure if it shows up very well or whether it's going to focus. But anyway, there is an arrow on one side of the cuvette which both shows where the which sort of plane the light should travel through. So in this case, you've got a very transparent side and a sort of frosted side. So the light's going to go through in this direction, not through that direction. And it also shows the level to which you can fill the cuvette. So we've got our 4 degree sorted, and I'm just going to do the rest in a similar manner. I'm not going to narrate it all because it's just the same thing. Okay. And I should note that in between each of these cuvettes I am thoroughly rinsing out this pipette in in a beaker of distilled water off to the side, which you can't see, but I am making sure that as minimal amount of pigment is left over between the two, or between successive temperatures as is possible. We're on to our 30 degree now. I'm just going to speed up a bit because I'm aware that for every second, every unit of time that these cores are still in a liquid is potentially time in which more pigment is leaching out. However, I'm factoring into account that I did leave about a 15 to 20 second gap in between adding each successive temperature to its water bath. So I'm just going to be quite quick about it so I don't run the risk of messing with our results. Wouldn't want that. I would see there is actually a difference in colour, not just in intensity of the same colour, but a difference in colour across this spectrum. It'll be interesting to hear why you think that might be. Okay, so while I'm putting these on, I'm just going to say that when we're using these little colorimeters, or spectrometers, whatever you want to call them, colorimeters we'll say, it is quite important that anything that goes into them be dry so you don't mess up the electronics inside. I've been quite careful, I don't see any moisture on the side of anything, but just going to double check. And we're going to be using a reference cuvette of distilled water, so that's our comparison effectively. Maybe use this is we're going to make sure that we've got the transparent side. Again, trying to make the camera focus on this. So we've got this sort of translucent side, and then you've got the transparent side. So we're going to make sure the transparent plane is lined up with our arrow indicated here. So it's going that way, that's where the light's being transmitted. Put it in there, and in this case we're just going to put R. And that gives us a 0 reading for absorbance, which is good. Although I believe I'm going to put it to transmission or absorbance. I'm going to take measurements for both. So yeah, we'll leave it at that. We'll go 4 degree. Where's my pen? So we've got 0.2. And I'll tabulate the absorbance readings in a separate thing off video, just so I don't bloat the video for too long. Our 20 degree. And we don't have to re-reference it each time. The colorimeter is clever enough to remember the reference value. 30 degrees, 0.32. 60 degrees, or what was supposed to be 60 degrees is actually 65. Oh no, it was 60 in this case. 1.16. And these are, I don't think these have a unit measurement for them, absorbance, it's just arbitrary units if you're ever doing work with them. 1.44. Although absorbance is inversely proportional to transmission. A bit of maths involved there, I'm sure. And 0.98, interestingly. So as I said, there is a distinct difference in colour between the 70 and 80. I'm not sure if you might be able to tell the difference there if I hold it up to the light. So although this is the 70 degree one, and this is the 80 degree one, the 80 degree has given us a lower I should say absorbance, I apologise, has given us a lower reading for absorbance. So I'll be interested to see what the results are for the different wavelengths of light, which I'll be doing shortly after I turn off the camera, because this is all you need to do for RP4. I think that's everything covered. As I say, I'll be tabulating the rest of the data for different wavelengths, and we'll see what the data shows.